Today we're going to be talking about architecture. This is a very hard thing to talk about because everyone's got their own way. Different games require different architecture depending what you're building. So this isn't a one size fits all, but what it does, or rather what we're going to talk about, is just some ideas to think about, some concepts to keep in mind when you are talking about how should your game be built? What should the components be doing? How do they behave? And how do you keep a little bit of consistency? So, yeah, we're not going to be looking at too much code today. We're just going to be looking at this is just a Unity scene I have here, just trying to build out um, a game, but trying to follow some very good architecture. So what we have over here are core systems. You can see on the left, there are core systems. There's a game scene, and then there's other scenes. But actually, we're just using this to compose and build things. When I hit play, if you watch what happens in our hierarchy over here on the left, when I hit play, we are going to see it disappear. It cleaned up and it's loaded and everything is hooked up. So that is what we're going to be talking about is how do we, one of the big challenges is actually trying to make good, effective use of Unity's lifecycle methods. For those that are relatively new to Unity, the lifecycle methods such as start, update, on-enable, on-disable, we are talking about things that are part of the modern behavior that allow Unity to then iterate through each object and then run their lifecycle method. So, what we have here is an architecture based on additive scenes. So we always have a core set of scenes, we can see up here, and then we have everything else. If you just think of core and everything else, that is a great way to try to understand what is going on. So I will just have a little bit of a rundown of it. Here we have our message bus to allow inter-object communication. We'll talk about more how we use that. We have a scene manager that is loading scene groups, because sometimes you don't want to load just a single scene. Sometimes you want to load a group. We have an audio service, just dealing with everything to do with audio. Our object pooler, which is all the objects and all the pooled stuff. An announcer. This we have carried from a previous project. It's a way of just displaying something on the screen. Really great for just debugging. So you can just spit out not only to your console, but on the screen you can sort of see here's some placeholder text of where the announcement will happen. And then we've got the player input manager, because while the player input, it would seem logical to be on the player character itself, you need to reach for it more often than not, which means that you need to reach within a different scene to try to get access to the player input. So why not just pull it out and have it as a core scene? So what is a core scene? What is this concept? Let's actually just quickly jump over here to the drawing tablet, and we can try to start to explore actually what is going on with the core scene. So, a core scene is something that we have determined must always be active. These are what we are considering to be part of our core scene, which means that we have full control and we want to have full control of the scene. Because we're using additive scenes, the way we're working is that we enter, load, core. Once core is loaded, we have everything else. So if we can guarantee these steps in order, then we can have full control of all the lifecycle and more access to the lifecycle of objects throughout the game. So think about it this way. You have you have the player, and you have an awake function, and then you have another object, and you want it to also do some stuff on awake that is saying maybe get player. But the thing is, these two are both on awake. And that means that it starts to become problematic as to how do we actually deal with having them access each other and access things that are very critical. And when we mean critical, we mean it is a core behavior. Say we want to start binding to the audio service. We want to do something on the message bus. We want to get the player input. If we always have to check player input manager, if we always have to check if it exists, we don't have full control of it. So that is why I say if we can start using additive scenes with an entry, a load, and then everything else, whenever everything else needs to access anything from our loaded core scene, we have already guaranteed that the core scene is there, and we can always reach for it, and we can do it in awake, start, enable, because we don't have to worry about the race conditions that all of these have if they all need to do something at the same time. For example, say in our audio service, if we say unenable, and it had to do stuff, but then our player on awake then had to get something from this audio service, the audio service is not ready because awake happens, then we have enabled, then we have start, etc. We have a huge problem with this happening first, that happens second, and this is not going to work for us. So by having the core scene always loaded before everything else, we always guarantee very good architecture for the rest of our scenes and the rest of our game objects, and we can always get the message bus, the scene manager, we can always access our player input, we can always access our audio service, we can always access our pool manager. We can get all these without any problems because we know they exist. So that is one of the architecture we are talking about. Scene manager, let me just bring it back. Its job is to load and unload scenes. When its scenes are not loaded or unloaded, we have a way to make sure that we are unloading unused scenes. We are not having anything that shouldn't be in the game loaded up at any given time that we do not need there. So actually, what does that mean? Yeah, let's have a look. I'm just going to hit play. We're going to jump in and we're going to see, okay, we have a call, we have a game scene. I'm now going to activate this. It's a little fishing spot. We have now activated the UI fishing because we are now in the fishing state. So let's do some fishing, all of that. Yep. We are just trying to fish for something. Let me just go through this. Bear with me. There is a lesson here. And we are completing this. And now that we are done, we're finished. As you can see, there is the UI completely unloaded. It's out of the way. We don't have to worry about resetting any of its parameters, creating some null state for it to then be resting there dormant, waiting to be used, waiting to be instantiated. We don't have to worry about it being dirty. It has been unloaded, it is gone. That is the job of the scene manager, is to load scene groups. So what we have is we have a good single point of entry of the core systems will always start up first, because the scene manager, even though other core systems or this loads, the scene manager is going to perform some reloading to make sure things are loaded in order. What is the message bus, and why is a message bus useful? So let's jump back to our drawing tablet and talk about the message bus. The message bus is part of our core scene, and it allows us to communicate between objects. So sometimes you want to have hard references, and every time we are creating some class, we are creating a hard reference to the player, which means that from the inspector, we'll have to assign something here, or we can have it do a bind first object with tag, etc., to actually assign our player. So we're creating a hard binding over here. Now, we want to make sure that sometimes between objects, we have got, so let's say these little squares, oh god, these are terrible squares. These squares are all our different objects. This is our scene, and I'm going to just draw something off to the side. So we have got some kind of reference for, and so let's just call it game, and the other one also has all these objects. When you're trying to decide how should these be bound together, do you use this principle, especially when we're talking about inter-object? We want to have a layer here. That layer is going to allow us to then communicate either between objects or objects between scenes, because sometimes you can't afford to have a hard reference, especially between objects in scenes, until it is loaded within the scene hierarchy, within the game hierarchy. Then you can have a hard reference. But until that, you cannot actually, in the inspector, take something from one scene and another and reference them. So this guy, this message bus, he subscribes, sub, and pub. So subscriber and publisher. If you've dealt with any of the Unity events or any events in general, you'll be very familiar with this pattern. Sometimes you might see it online as raising and registering. These are more or less the same concepts. So we are subscribing to some event on the message bus, and we are also, say, from this scene, we are now publishing some event on the message bus. And actually what happens is that when the subscriber hears the publisher through this message bus, you have this data being transferred to the subscriber from the publisher, and that is how you communicate between objects, especially across scenes. In fact, this allows you to do some very interesting things like completely decoupling your scenes or your objects so they've got no hard references, as long as you're making sure that if it fails and it fails silently, you're capturing that. But we're not going to highlight on what that is. We just want to talk about architecture. So using a message bus allows our inter-scene communication. It allows our inter-object communication. So you can have, say, this guy go this way and this guy go this way. So now you have on the same scene your data flowing to him from 1 to 2. Then when you're deciding, okay, hey, what do I do with the core then? The core is just off to the side. Does it also use the message bus? Yes, you can. However, if you know from earlier, that the core system is actually always going to be online, and you don't have to worry about knowing whether core exists or not, because core always exists, and that is an architectural truth that we have determined in this from our entry. We'll say that always exists. That means our scenes can always get hard bindings to core. Let's just use this dark orange as core. These are all, let's call this instanced singletons, which means that every single one of these can always call, for example, our audio service. Let's just call it as.instance.play sound effects. You can always do this in every object, because we don't have to worry about, does the scene exist? Does the object exist? We are always going to guarantee an instance will always exist, because that is what we have promised over here, that the core scenes always exist. So now we have an architecture where scenes communicate between each other through a message bus. They can always get a hard reference to core game objects, and your core game object can be a lot more than just the message bus, audio service, pool manager, whatever you deem core that every scene in your game has to have access to. Add it in there, and you will have a very easy way of controlling. It does mean that, you know what's the very neat thing? Because core is always there and it always exists before everything else, you can now even reference on awake. You can reference on awake all these. Every single one of these objects can hit awake or hit enabled or start, and they can each get the audio service instance, because we don't have to worry about the race conditions anymore. We don't have to worry about, is the audio service actually there? Under this architecture, it does work. So let's move along. Remember, we had a look just a moment ago when we were trying to do a little bit of fishing, that we saw the UI scene pop up. We have settled on an architecture where there is always a handler in the game scene, and the handler will always reach out, or will always be waiting for some signal to then spawn the scene. Now, I did say that we're not going to look at any code, but let's actually see some use of that. Let's get rid of all of that. So dialogue, we've got, say, a dialogue handler, and what it says is we've got our message bus dubbed equal, and we have subscribed to a begin dialogue and end dialogue. Now, just so we know, when we go back to our game scene, the dialogue handler is in our game scene, and in fact, when we hit play, the game scene is loaded and the dialogue handler is always there, which means that it is always listening and it's always waiting. So this is also another architectural truth we have determined to be very beneficial for us, is a handler will always be waiting in the game scene for some logic to happen, so that we can bring up the actual scene that it is handling. In this case, we are handling the dialogue. So when we do get an on begin dialogue event, we are going to pass in some data that we need, and then we are going to load in the relevant scene or scene group. We're using scene groups. I'm not going to go over the technicalities of that. For now, we are using scenes. We're going to load up the dialogue scene, and we're going to pass it the information it needs. And stuff is going to happen throughout the dialogue, and eventually we are going to end the dialogue. So at some point, there's going to be a signal coming from somewhere that says end dialogue. And in this case, the end dialogue is going to trigger in the handler, and the handler will go, okay, cool, let's unload everything that we don't need and load the scene back to where it needs to be. So as we can see, the handler sits outside of our scene that we are loading, and it just deals with loading and unloading and making sure the data it has is available. That is another truth in our architecture, in that handlers always exist in the game scene, and they will always bring up relevant scenes as we play the game for whatever part of the game we're in. The game will then continue with those scenes, and when that part of the game is done, when those gameplay features are no longer required, we are unloading that and we're returning back to a sanitized state. The other truth is within our core scenes, we have determined that everything in our core scenes is hardbound, so it's by reference. We're calling the instance of it, and we're saying, hey, does the instance exist, as we mentioned earlier. That's all I have to talk about. I hope you've stayed long enough for this rant. I know this has been a bit of a long video, but I do hope that talking about architecture got you thinking about how you should design your game, how you should work with an architecture that best serves you. Not everything here is great for every project. There are definitely some limitations to this. We have yet to come across it. It is still early days, but the important thing that I do want people to keep in mind is, when you have an architecture, stick to it. It is very easy to simply say, you know what, I just want to add a game object here that just does everything for that one feature, and I'm just going to do that because that's easy. The problem later becomes down the road, when you're starting to reach that point where you're polishing the game and you realize that, no, I want object A and object B to actually be communicating to object C, and you realize that A, B, D, E, F are all hardbound together, and now you cannot separate that. And that's what happens when you don't follow your own architecture. So, I hope you've had a good time listening to me rant, and if you haven't yet, like, subscribe. Thanks for listening, and have a great time.